Welcome to solverfy.
Hello everyone, in this problem it is given there is a beam this is the point A on which force of 650 Newton is applied and it makes 30-degree angle with vertical. This is the point at which force of 300 Newton is applied and this is the point at which 500 Newton force is applied, and this angle is given 60 degree. Mark this point to be P and Q, and this is the point B. Now this distance is given 3 meter and this distance is given 5 meter and this is given 2 meter. We have to calculate net force on the rod and moment of torque or moment of force about the point A. First, do the naming. Suppose this is F1 force, this is F2 force, and this is F3 force. We will resolve F1, F2 and F3 into its component, that is along x-axis and y-axis. So F1 can be written as 650 sine of 30 I cap minus 650 cos of 30 j cap. When you substitute the value, F1 force will be 325 I cap minus 563 j cap Newton. Now F2 force is along negative y-axis, so this can be written as 0 I cap minus 300 j cap Newton. Now we have to resolve F3 force. So F3 force could be written as minus 500 cos of 60 I cap minus 500 sine of 60 j cap. So F3 force we will get minus 250 I cap minus 433 j cap Newton. Say this equation is second and this is the third. So resultant force on the beam you will get vector addition of F1, F2 and F3. Now substitute the value. F1 is 325 I cap minus 563 j cap plus 0 I cap minus 300 j cap. This is the value of F2, and F3 is minus 250 I cap minus 433 j cap. So on solving, resultant force on the beam will be it will be plus 75 I cap minus 1296 J cap Newton. You can see the diagram. I am drawing the diagram of this resultant force here separately. This is x-axis, this is y-axis. So the resultant force you are getting this one, and this is the angle. Now you can write its magnitude. Magnitude of this force will be 75 square plus 1 minus 1296 whole square. When you solve it, this magnitude will be 1298 Newton or 1.3 kilonewton, and this angle theta will be tan inverse of 1296 divided by 75, and it will be approximately 86.7 degrees. So this is the answer for net force. Now we have to find moment of force about the point A. Moment of force about the point A we are calculating. F1 force is acting at A point itself, so its moment of force will be 0. F2, its position rotating arm vector is AP cross F2 plus AQ cross F3, and already it having the moment 1500 nanometer in anti-clockwise direction. AP vector is 3 I cap, or F2 is minus 200 J cap. AQ is 8 I cap vector cross F3 is minus 250 I cap minus 433 J cap nanometer. Now when you simplify, you will get this is to be minus 600 K cap, and this value will be here, sorry, F2 is 300 force, so this will be 900, and if you simplify this, it will be minus 3464 K cap, and this is 1500 Newton meter. Negative K cap means clockwise direction, so this could be written as 28, or sorry, just a moment please. You can write this force to be, just a moment please, sorry, 4364 Newton meter in clockwise direction, and this is 1500 Newton meter in anti-clockwise direction. So your answer will be 2864 in anti-clockwise direction, or you may write 2.9 kilonewton meter in anti-clockwise direction. So this is the answer for this problem. Thank you for watching the video.